Students, look at the question. You should find out how many CO group present in the tripeptide. That tripeptide is made up of ASP, GLU and LYS. We know that peptides, they are the condensation product of amino acids. Am I right? So when I will tell you tripeptide, the tripeptide is made up of the 3 amino acid molecules. Let's show now the amino acid molecules. Everyone show this. We have amino acid, right? Once again we are writing amino acid. Once again I am writing amino acid. Right? Everyone know this, H and OH go out as water, so there is a amide bond. OH and H go out as water, there is a peptide bond. So we have a tripeptide, and already you can see in the tripeptide there is a 1 CO, 2 CO and 3 CO groups are present. Already I have seen 3 CO groups. Now let me see what are these amino acid molecules made up of. ASP stand for, students, you know, aspartic acid. So CO is here also. GLU stand for glutamic acid. Acid means even CO is present here. Lysine, we all know that lysine is a basic alpha amino acid. So COOH I won't get from here. So total 1, 2, 3, 4, 5. There are 5 CO groups are present, but still let me clearly show you this. If you have idea, without writing any structure, you will be able to tell me the answer. So that is how I shown you here the same thing. Now let's discuss this in detail. Now everyone see this. I am writing amino acid, both attached to alpha carbon, so alpha amino acid it is. The general are 1, 2, 3 and 1 is 4. Okay, now see this. If I will write in the place of R hydrogen here, it will become the simplest alpha amino acid, and the name of this simplest alpha amino acid is glycine. Let me tell you, R is replaced by H, right? So this is the simplest alpha amino acid. This carbon is achiral because identical hydrogens attached. So this particular alpha amino acid having no chiral center. Due to the absence of chiral center, we call alpha amino acid glycine as optically inactive. I hope everyone understood this. Now you replace R by methyl group, so glycine become alanine. It become alanine. Remove one H and in the place of H you write the OH. It become serine now. It become the serine. Okay. In between OH and CH2 you show the tire of benzene ring. Okay. So in between the CH2 and OH I shown a tire of benzene ring. Tire I said no. The Benz car I said no. So tire of the Benz car, it is tyrosine. It is tyrosine. Again I will come back. In the place of R, I wrote H, it become glycine, simplest alpha amino acid, optically inactive due to the absence of chiral center. Now I replaced R by methyl group, I got alanine. I removed one H of the alanine and in the place of that one H I wrote one OH, it became a serine. In between CH2 and OH of the serine I shown a tire of benzene, it became tyrosine. Now let me go ahead. In the place of R I will place methyl. I know this is alanine. Now what I will do is I will replace one H by the COOH group. Now it has become aspartic acid. It has become over here aspartic acid. Acid base neutral, neutral acid, acidic alpha amino acid. Example is aspartic acid. Acid base together become a neutral, neutral and acid become acidic alpha amino acid. I can see over there aspartic acid. Now exactly what I should write is over here CH2COOH. Now what I will do is I will just add one more CH2 here. Now aspartic acid become glutamic acid. The symbol of glutamic acid is GLU, right? So I am seeing here a glutamic acid. So in the place of R, what we need to write is CH2CH2COOH. Here also let me write it as a COOH. Okay. Now what I will do, you check. See this. I want to write the basic alpha amino acid. I want to write the basic alpha amino acid. Base, BASE. So CH2 twice is here. You make it CH2 4 times. A base means there should be amine, NH2. All of you can see acid and base become neutral, neutral and base become basic alpha amino acid. So all of you all can see the structure. What I have written here is the structure of lysine. And let me tell you people that lysine is an example of the basic alpha amino acid. So here LYS indicate the lysine and in the place of R let me write now CH2 4 times NH2. Now everybody can clearly see that we have a CO1, CO2, CO3, CO4 and CO5 and what answer we ticked here, it's absolutely right.